Solve for x in the equation ln of x minus 2 plus ln of 2x minus 3 equals 2 ln x. So in this particular equation we've got a bit of work to do, some manipulation required before we can undo the logs by raising the base to the power of both sides. We're definitely not in a position where we can do that because of both sides actually. The first side is a sum of two separate logs, so we need to turn that into a single logarithm. And the right hand side, well, you've got a 2 in front of it, and you can't undo a log if you've got a multiplier in front of it, so we need to use the third law on that. So let's get to work. Ln x minus 2 plus ln 2x minus 3 equals 2 ln x. So what we're going to do, we're going to use the first law of logs on this, so we can say, well, this is ln of the product of these two terms. So ln of x minus 2 to x minus 3 equals, and now what we're going to do is use the third law and put the 2 up there as a power, so equals ln of x squared. So now we're going to have to deal with this bracket, which is so ln of 2x squared minus 3x minus 4x, that must be minus 7x plus 6 equals ln of x squared. So now we can undo the logs, and what we're doing, we're raising e. E, remember, is the base for a natural log, e to power of both sides. And I'm actually not going to do that. I'm just going to sort of forget the step that I have been showing. I'm just going to write 2x squared minus 7x plus 6 equals x squared. If you think about it, we take a log of one thing equals the log of the other, then the arguments must be the same anyway. 2x squared minus 7x plus 6 equals x squared. It's looking like a quadratic. If we just subtract that x squared, it'll be great for 2, isn't it? It will leave a 0 here, and it will make this a lot easier to hopefully factorize. So 2x squared minus x squared minus 7x plus 6 equals 0. Look to factorize x, and it looks like we need same sign, so minus 6 minus 1, minus 6 plus minus 1, minus 1 minus 6 equals 0. So that would mean x equals 1 or x equals 6. So that is what's implied, but remember, even though we didn't necessarily end up seeing it, we did do this. Once we have done this, we have actually changed the equation into a different equation, potentially. What we are solving here, the solutions of this equation are absolutely x equals 1 and x equals 6. It does not mean both of these solutions will be solutions to this. We need to check them. We're going to substitute into the original equation. Substitute into original equation. So we're looking for things like, do you end up taking a log of a negative number, or does the equation actually hold when you're doing this? So if I just look at this, so when x equals 1, dot dot dot. So we're looking ln, it's going to be 1 minus 2. This is a problem straight away. So ln 1 minus 2 plus ln 2 times 1 minus 3. Another issue, does that equal 2 ln 1? So 2 ln 1 is going to be 0. Here you end up taking, so ln of minus 1, there isn't a log of minus 1, plus ln also minus 1. Does that equal 0? Well, actually this definitely doesn't work. There's no solutions to this, because think what ln of minus 1 is. It means what power do you raise e to in order to get minus 1. So if you had a graph of e to the power x, it looks like this. goes through at 1, 0, and it has an asymptote, horizontal asymptote at y equals 0, so it's never going to get to -1. There doesn't exist a solution, so no solution. Well, actually, I'll probably just put x equals 1 is not a solution. So really, we're just disregarding this one. It's not going to work. Right. So hopefully the other one will work. So if x equals 6, when x equals 6, dot dot dot. So we have ln. I'll try and do this in one line because I'm running out of space. So ln 6 minus 2. Well, that must be ln 4 plus ln 2 times 6 minus 3, so that would be 12 minus 3, ln 9. Does that equal 2 ln 6, right? Is that true? Well, if you look at the first law, this would be ln 36, which we just multiply them. Does that equal ln 6 squared using the third law? Yes, absolutely. ln 36 is ln 36. So, final answer, x equals 6 is the only solution.